Hello, this video will talk about Lab 11. In Lab 11, you'll be extending the graph application developed in Lab 10. It says Lab 9 in the notes, but it's Lab 10. And you'll be estimating an optimal solution to each of three problems. Now, those problems are pretty straightforward because Dr. Lee from the math department recorded some videos, 4 videos, about each of those three problems. So the application will replace functions 1, 2, and 3 with the 3 functions developed in the videos for finding local extrema. So there are, as in Lab 10, there are 3 methods that you need to implement. The two-string method for each function. The functions, function 1, function 2, function 3, extend function, which is an abstract class. Two-string function value, which returns the f of x for each value of x of the function with respect to the function, and the answer string, which records the answer. So you will need to follow the tasks, but they are very straightforward. Based on the video, which I repeated down here again, there are 3 answers to the 3 problems. Here is the first answer, the first function value. So for every value of r, or as we call it x, there's a function, f of x, that you need to evaluate. That's all that function value does. It returns the value of the function for any value of x. The two-string and the answer string are simply, the two-string is describing the initial problem, and the answer string is describing the optimal solution. So the video explains the second problem, playing fetch, and you throw the ball out into the water. Now, being an optimizing dog, the dog runs partway along the beach and then jumps in the water. Is there any way, the question is there any way he could reach the ball faster? And once again, here is the function. There's no box around it this time, but q of x is equal to that function. And then problem 3, task 3, is an optimization of the closest point on a parabola from q sub 0, 1. Actually, there are 2 closest points, the negative and the positive. So you just need to find the positive and then display it as a positive and a negative value. And then, of course, upload the files. So that's all there is to Lab 11. It's not easy, but it's also not complicated. So let me show you on in Eclipse the running of this problem. So we want to optimize, let's say, problem 1. Again, we have left and right extents. Now the can't be a negative value, so it starts at 0, and the radius of the can't be a negative value. and I don't know what the right value would be. Maybe it was say 10. So that looks like the minimum cost is $221, etc. And then the graph is plotted. You notice that the 0 point is probably right about here. So this eliminates the requirement to talk about local extrema and minimum and all the things that you learn about in calculus. But, of course, just like Lab 10, the answer is a little less precise than the calculus answer. So that is the essence of Lab 11.